welcome to this deep dive
Yeah.
where we'll be kind of exploring the fascinating world of scientific discovery,
Right.
through the lens of 5 Nobel Prize-winning lectures.
Okay.
We've got excerpts from Wolfgang Pauli, who really revolutionized quantum mechanics,
Yeah.
Paul Crutzen, who unveiled the human impact on the atmosphere,
Right.
Ronald Ross, who cracked the code of malaria transmission,
Okay.
Georg von Békésy, who transformed our understanding of hearing,
Yeah.
and Bertram Brockhaus, a pioneer in using neutron spectroscopy to understand matter at the atomic level.
Okay.
Are you ready to kind of get into it?
Absolutely.
Yeah.
What's really interesting about these lectures is how they reveal the interconnected threads of ingenuity, observation, and impact across seemingly different fields.
Yeah, I love that. It
Yeah.
reminds me of how a single thread can connect an entire tapestry.
Right.
So where should we start with all of this amazing material?
Well, let's begin with Ronald Ross and his work on malaria.
Okay.
His story highlights the power of meticulous observation.
Right. And how a single insightful observation can lead to a major breakthrough.
Okay. All ears, tell me more.
So for years, Ross meticulously dissected mosquitoes searching for the malaria parasite.
Yeah.
He was following a hunch from Patrick Manson, who believed mosquitoes transmitted the disease.
Okay.
But it wasn't until Ross focused on a specific type of mosquito, those with dappled wings,
Oh.
later identified as anopheles,
Okay.
that he had his eureka moment.
So it was a specific detail, the dappled wings, that led him down the right path.
Precisely.
Okay.
He noticed that these mosquitoes had the malaria parasite in their salivary glands.
Okay.
That observation was the linchpin connecting the mosquito to the spread of malaria.
Yeah.
This wasn't just about looking closely.
Right.
It was about seeing the right things, the subtle details that others might have missed.
It makes you wonder how many other crucial details we might be overlooking in our own lives simply because we aren't looking closely enough or with the right perspective. It's a good point. Ross's story also reminds us that groundbreaking discoveries often face resistance. The scientific community initially met his findings with a lot of skepticism.
Yeah, it must have been incredibly frustrating to be so sure of your findings but have others doubt you.
Absolutely.
Yeah.
But Ross was tenacious.
Right.
He spent years gathering more evidence, defending his theory,
Yeah.
and ultimately changing the way we understand and combat malaria.
Wow.
It's a testament to his perseverance,
Yeah.
but it also highlights how science sometimes requires a bit of a fight to get those revolutionary ideas accepted.
Makes you wonder about all the brilliant ideas out there that might have been dismissed before their time.
Right.
It makes me think about Georg von Békésy and his work on hearing.
Yeah.
He walked into a field where research had been stagnant for decades.
That's a great segue,
Yeah.
because von Békésy's story embodies both the power of observation and the courage to challenge the status quo.
Right.
His initial inspiration came from something completely unexpected: telephone lines.
Telephone lines. What do telephone lines have to do with the inner ear?
So von Békésy was fascinated by how telephone lines transmitted vibrations,
Okay.
and he wondered if a similar principle could be at play in how we hear.
Right.
He was looking at a seemingly mundane, everyday object
Yeah.
and drawing a connection to a complex biological system.
That's incredible. It's like he was seeing the world through a different lens, finding connections that others missed.
Exactly. And he didn't stop at just the observation.
Yeah.
He was a master model builder.
Okay.
To study the mechanics of hearing,
Yeah.
he created physical models of the inner ear, even going so far as to use his own arm as a stand-in for a nerve supply.
His own arm. Wow, that's dedication. But what kind of insights could you gain from a model like that?
Well, von Békésy was trying to understand how sound waves traveling through the fluid of the inner ear
Okay.
ultimately get translated into the nerve signals our brain interprets as sound.
Right.
His models allowed him to manipulate different variables,
Okay.
study the movement of the fluid, and ultimately discover the principle of the traveling wave.
Okay, hold on. What is a traveling wave and why is it important?
Imagine you drop a pebble in a pond.
Okay.
You see the waves ripple outward, right?
Yeah.
Von Békésy found that a similar wave-like motion happens in the cochlea, the spiral-shaped structure in our inner ear.
Yeah.
Different frequencies of sound create waves that peak at different points along the cochlea,
Okay.
activating different hair cells, which then send signals to the brain.
So basically, different parts of the cochlea are tuned to different frequencies, like a piano keyboard.
That's a great analogy.
Okay.
And this discovery completely revolutionized our understanding of how we hear.
Wow.
It laid the foundation for advancements in hearing aids, cochlear implants, and our understanding of hearing loss.
So it seems like both Ross and von Békésy used observation in very different ways, but both had this amazing impact.
Exactly. It shows that there isn't just one scientific method.
Right.
There are many paths to discovery,
Yeah.
and observation is a key ingredient in all of them.
Now I'm curious about Wolfgang Pauli and this whole quantum mechanics thing.
Okay.
I have to admit that area of science always seemed a bit mysterious to me.
Well, Pauli gave us one of the most fundamental principles in quantum mechanics, the exclusion principle.
Okay.
It might sound complicated,
Right.
but it essentially explains why matter is stable and why atoms don't just collapse in on themselves.
Okay, so tell me why matter doesn't collapse. I'm all ears.
Imagine electrons like they're trying to find a seat on a very exclusive bus.
Okay.
The exclusion principle states that no two identical electrons can occupy the same seat or quantum state.
Right.
Each electron needs its own unique set of quantum numbers,
Got
which
it.
describe its energy spin and angular momentum.
Okay, I'm following so far. But what's spin? Is it like the Earth spinning on its axis?
Not quite.
Okay.
Electron spin is an intrinsic property of the electron.
Right.
It's a bit like a tiny internal magnet with a north and south pole.
Okay.
And because of the exclusion principle,
Yeah.
two electrons in the same orbital can't have the same spin.
One must spin up and the other down.
So it's like this rule of the universe that keeps things organized and prevents electrons from all crashing into each other.
Precisely.
Okay.
It's this beautifully simple but incredibly profound principle
Right.
that governs the behavior of particles at the subatomic level
Yeah.
and ultimately influences everything from the structure of atoms to the properties of materials.
It's mind-blowing to think that something so small and seemingly abstract can have such far-reaching consequences.
Yeah.
It makes you wonder what other seemingly simple rules govern the universe that we haven't discovered yet.
It's a truly tantalizing thought.
Yeah.
And it leads us to another fascinating aspect of scientific discovery.
Yeah.
The role of technology in pushing the boundaries of what we can observe and understand.
Right. Yeah.
Speaking of tools and technology, let's shift gears to Bertram Brockhaus and his groundbreaking work in neutron spectroscopy.
Okay.
His story is all about how advancements in technology can unlock entire new avenues of scientific exploration. So how does neutron spectroscopy work? I have to admit, I'm not even sure what a neutron is, let alone how you use it to study matter.
Well, a neutron is a subatomic particle found in the nucleus of an atom.
Right.
What makes them so useful for studying matter is that they have no charge.
Okay.
This means they can penetrate deep into materials without being deflected by the electrical charges of protons and electrons.
So it's like having a tiny ghost-like probe that can sneak past the outer defenses of atoms and see what's going on inside.
That's a great way to put it. Neutron spectroscopy is all about firing a beam of neutrons at a material
Okay.
and then carefully measuring how those neutrons scatter or bounce off the atoms within the material.
All right.
The way the neutrons scatter reveals crucial information about the structure and dynamics of the material at an atomic level.
Okay, I'm starting to see how this could be powerful, but how did Brockhaus contribute to all this?
Brockhaus was a pioneer in developing and refining the techniques of neutron spectroscopy.
Okay.
He developed something called the triple-axis spectrometer, which became a crucial tool for studying the structure and dynamics of matter in various forms, from liquids and solids to magnetic materials.
So this triple-axis spectrometer was a big deal. What made it so special?
Well, this spectrometer allowed scientists to very precisely control and measure the energy and momentum of the neutron beam,
Okay.
both before and after it interacted with the sample.
Right.
This level of control and precision opened up a whole new world of possibilities for studying materials at the atomic level.
It's amazing how these technological advancements can suddenly allow you to see things that were previously invisible. It's like putting on a new pair of glasses that reveal a hidden layer of reality.
Exactly. And Brockhaus's work was instrumental in advancing our understanding of condensed matter physics,
Right.
the study of the properties of solids and liquids.
So
He was a true pioneer who laid the foundation for a field that continues to flourish today.
it seems like a common thread among all these Nobel laureates is this willingness to push the boundaries of what's known, to challenge the status quo, and to forge new paths, even when faced with resistance.
Absolutely. And that brings us to another remarkable scientist, Paul Crutzen.
Okay.
His work on atmospheric chemistry not only revolutionized our understanding of the atmosphere,
Right.
but also raised global awareness about the impact of human activities on our planet.
So tell me more about Crutzen's work. I know he's often associated with ozone depletion, but what exactly did he do?
Crutzen's early work focused on developing numerical models to predict weather patterns.
Okay.
But his interests soon expanded to the chemistry of the atmosphere
Right.
and the complex interplay of gases that influence our climate.
Okay.
He became particularly interested in nitrogen oxides
Yeah.
and their role in atmospheric reactions.
Nitrogen oxides.
Hmm.
Aren't those pollutants from car exhaust and industrial emissions?
That's right.
Okay.
But what Crutzen and his colleagues discovered was that these nitrogen oxides also play a crucial role in the natural cycles of ozone in the atmosphere.
Okay.
Ozone is this remarkable molecule
Right.
that shields us from harmful ultraviolet radiation from the sun.
So there's good ozone and bad ozone.
Exactly.
Yep.
In the stratosphere,
Right.
ozone is beneficial protecting life on Earth.
Yeah.
But in the troposphere close to the ground,
Okay.
ozone is a pollutant harmful to human health and ecosystems.
Right.
What Crutzen and his colleagues found was that human-made nitrogen oxides,
Yeah.
particularly those released from supersonic aircraft flying in the stratosphere, could contribute to the depletion of the protective ozone layer.
That's a pretty significant discovery.
Yeah.
So he basically found that human activities could have unintended consequences for the entire planet's atmosphere.
Precisely. Crutzen's work, along with that of many others,
Right.
led to a paradigm shift in our understanding of the fragility of Earth's atmosphere.
Wow.
It sparked a global movement to phase out ozone-depleting substances,
Yep.
and ultimately led to the Montreal Protocol, a landmark international treaty that has successfully protected the ozone layer.
It's inspiring to see how scientific discoveries can actually lead to real-world solutions to global problems. It's like science can be a force for positive change in the world.
Absolutely. Crutzen's story also highlights the importance of effective scientific communication.
Right.
He didn't just publish his findings in scientific journals.
Sure.
He actively engaged with policymakers and the public,
Okay.
raising awareness about the issue of ozone depletion and advocating for solutions.
It's a great example of how scientists can be more than just researchers.
Right.
They can be advocates, educators, and communicators playing a vital role in shaping public policy and understanding.
And speaking of public understanding, one thing that really struck me about these Nobel lectures was how each laureate emphasized the importance of sharing their knowledge with the world.
Okay.
They saw science not as an ivory tower, but as a vital part of human culture and progress.
That's such an important point. Sometimes science can feel very specialized and inaccessible.
Yeah.
At its core, it's about understanding the world around us and sharing that understanding with others.
Exactly. And these Nobel lectures are a fantastic example of how complex scientific concepts can be explained in a way that's both engaging and insightful.
Right.
They remind us that science is a human endeavor driven by curiosity, creativity, and a desire to make sense of the world.
It makes me think about how we can all be better communicators of science, even if we're not Nobel laureates. We can all share our enthusiasm for science with friends, family, and colleagues and help to break down those barriers between science and the public.
Absolutely. The more we can foster a culture of scientific curiosity and understanding,
Right.
the better equipped we'll be to tackle the complex challenges facing our world.
Now, I'm curious about the personal journeys of these Nobel laureates.
Yeah.
What were their motivations? What challenges did they face? Did they ever doubt themselves?
That's a great question because behind every groundbreaking discovery is a story of human passion, perseverance, and often a healthy dose of serendipity.
All right.
Let's start with Ross.
Okay.
He embarked on his malaria research while serving as a medical officer in the British Indian Army.
Wow.
Imagine trying to conduct groundbreaking research
Yeah.
while also dealing with the demands of a military career in a remote and challenging environment.
That's incredible. It speaks volumes about his dedication and resilience. He must have been incredibly passionate about finding a solution to malaria.
He was,
Yeah.
and his path was paved with setbacks, frustrations, and moments of doubt.
Right.
He faced skepticism from his superiors who didn't believe mosquitoes could transmit malaria.
Oh, wow.
He struggled with limited resources and primitive equipment,
Yeah.
and he even battled bouts of malaria himself.
It's like a real-life scientific adventure story.
Eh.
But what kept him going through all those challenges?
I think it was a combination of factors.
Okay.
He was deeply moved by the suffering he witnessed caused by malaria. He had an unshakable belief in his theory.
Yeah.
and he had a stubborn determination to prove his doubters wrong.
Okay.
His story reminds us that scientific progress often requires not just brilliance, but also grit, resilience, and an unwavering commitment to one's goals.
It's inspiring to hear how he overcame those obstacles and ultimately made a discovery that saved countless lives.
And speaking of overcoming obstacles, von Bakesy's journey to the Nobel Prize was also marked by challenges and serendipitous moments.
Right.
He was forced to flee Hungary during World War II,
Oh, wow.
leaving behind his laboratory and research.
That's heartbreaking to hear. To lose everything you've worked for and have to start over in a completely new environment.
Yeah.
How did he cope with all of that?
Well, von Bakesy had an incredible ability to adapt and innovate.
Right.
He saw challenges as opportunities,
Okay.
and he never stopped experimenting and exploring.
Right.
He had this amazing knack for finding inspiration in unexpected places.
Yeah.
Remember how his initial insights about the inner ear came from observing telephone lines?
Right. It's like he had this childlike curiosity that never faded. He was always looking for connections and patterns, even in the most mundane things.
Exactly. And that open-mindedness and willingness to embrace the unexpected played a key role in his breakthroughs.
Yeah.
One of his most significant discoveries, the traveling wave theory,
All right.
came from a serendipitous observation while working with a model of the inner ear.
Wait, what happened? Tell me more.
He was observing how vibrations traveled through his model,
Yeah.
and he noticed a wave-like motion on his own arm,
Right.
which he was using to hold the model.
Okay.
At first, he dismissed it as an artifact,
Right.
but then he realized that this wave-like motion
Yeah.
might actually be happening in the cochlea itself.
That's incredible. So his own body became part of the experiment and led him to a groundbreaking discovery.
It's a fantastic example of how serendipity can play a role in science,
Yeah.
but it's also a testament to von Bakesy's open-mindedness and ability to see the potential in an unexpected observation.
It makes you wonder how many other brilliant discoveries might be hidden in plain sight, just waiting for someone with a curious mind to make the connection.
And that brings us to Brockhaus, who started his scientific career during a time of remarkable openness and possibility in the field of neutron scattering.
Oh, wow.
He had the opportunity to work with some of the brightest minds of his generation,
Right?
and he was part of a team that was pushing the boundaries of what was known about the structure of matter.
It sounds like a very exciting time to be a scientist.
Yeah.
What was it like for Brockhaus to be at the forefront of this new field?
Well, it was a time of rapid progress and constant discovery,
Right.
but it was also a time of limited resources and technological challenges.
Yeah.
Brockhaus had to be incredibly resourceful and innovative in his approach.
Huh.
He had to build his own instruments from scratch,
Right.
often using whatever materials he could find.
Wow.
And he had to develop new experimental techniques to overcome the limitations of the technology available at the time.
It's like he was a scientific MacGyver.
Yeah.
But what motivated him to keep pushing forward despite those challenges?
I think it was a combination of curiosity, passion, and a deep belief in the power of science to unravel the mysteries of the universe.
Right.
He was fascinated by the fundamental building blocks of matter,
Yeah.
and he was driven to develop the tools and techniques needed to understand them better.
It's inspiring to hear how these scientists not only made groundbreaking discoveries,
Right?
but also paved the way for future generations of researchers.
Yeah.
They left behind a legacy of knowledge, tools, or inspiration that continues to shape the world today.
Absolutely. And their stories remind us that scientific progress is a collective endeavor, a tapestry woven together by the contributions of countless individuals across time and cultures.
It makes you realize that science is more than just a collection of facts and theories. It's a human story, a story of exploration, discovery, and the relentless pursuit of understanding.
It's remarkable to consider how each of these scientists working in different fields at different times all contributed to this vast and ever-evolving tapestry of scientific knowledge.
Yeah, it's like they were all adding their own unique threads to a grand design, even if they couldn't see the full picture themselves.
Exactly. And sometimes those threads connect in unexpected ways. Take Pauli's exclusion principle, for example.
Yeah.
It might seem like a rather esoteric concept confined to the realm of subatomic particles,
Okay.
but it turns out to have profound implications for understanding the universe on a much grander scale.
So how does a rule about electrons relate to the universe as a whole?
Well, one of the biggest mysteries in astrophysics is what happens when a massive star collapses at the end of its life.
Okay.
The intense gravity wants to crush everything down to a single point,
Right.
but something pushes back, preventing the complete collapse. That something is the exclusion principle.
Hold on, so you're telling me that tiny little electrons are holding up against the crushing force of a dying star?
In a sense, yes. The exclusion principle dictates that no two electrons can occupy the same quantum state.
Right.
So as the star collapses and the electrons are squeezed closer and closer together,
Right.
they start to resist further compression.
Okay.
This creates an outward pressure that can counteract the inward pull of gravity.
Wow, that's mind-blowing. It's like this tiny rule about electrons is playing a cosmic game of tug-of-war with the immense gravity of a star.
And in some cases, the exclusion principle wins out, preventing the star from collapsing into a black hole. Instead, it forms a super-dense object called a neutron star or a white dwarf.
It's incredible to think that something so seemingly insignificant on the atomic scale can have such dramatic consequences on the astronomical scale. It really highlights the interconnectedness of the universe and the power of fundamental scientific principles.
Absolutely. And it reminds us that science is full of surprises. We never quite know what connections we'll uncover or what seemingly simple rules might govern the universe in ways we never imagined.
Speaking of surprises, Crutzen's work on atmospheric chemistry also revealed some unexpected connections. Initially, he was just interested in understanding the specific chemical reactions involving nitrogen oxides and ozone, but his research ended up having much broader implications for our understanding of the Earth as a system.
That's right. What Crutzen and his colleagues discovered was that human activities weren't just affecting local air quality.
Yeah.
They were actually altering the chemical balance of the entire atmosphere, with potentially global-scale consequences.
So his work wasn't just about understanding a few chemical reactions, it was about understanding the interconnectedness of Earth's systems.
Precisely. It was a major step forward in the development of Earth system science, which recognizes that our planet is a complex, interconnected system where changes in one part can have ripple effects throughout the entire system.
It's like we're all living on this giant spaceship hurtling through space, and everything we do has the potential to affect the delicate balance of the life support systems that keep us alive.
That's a powerful analogy, and it highlights the importance of understanding these connections and acting responsibly to protect our planet. Crutzen's work served as a wake-up call, reminding us that we're not just passengers on Spaceship Earth, we're the crew, and we have a responsibility to steer it wisely.
It's inspiring to see how science can not only illuminate the workings of the universe, but also empower us to make informed decisions about our future. It's like science can be a tool for both understanding and action.
Absolutely. And that brings us to another important aspect of these Nobel lectures, the emphasis on the importance of mentorship and collaboration in science.
Yeah.
None of these scientists worked in isolation. They all benefited from the guidance and support of mentors and collaborators.
I think it's easy to imagine scientists as these solitary geniuses working alone in their labs.
Yeah.
But the reality is that science is a deeply social and collaborative endeavor.
Exactly. Science thrives on the exchange of ideas, the sharing of knowledge, and the collective efforts of individuals working together toward a common goal. And mentorship plays a crucial role in fostering the next generation of scientists and ensuring the continuity of scientific knowledge.
So it's like a torch being passed from one generation to the next, each scientist building on the work of those who came before them.
That's a great way to put it. And each of these Nobel laureates acknowledge the importance of mentorship in their own journeys. Ross credited Patrick Manson for inspiring his interest in malaria and guiding his early research.
Okay.
Von Becasey benefited from the mentorship of prominent physicists and physiologists who helped him develop his experimental skills and refine his ideas.
Right.
And Brockhaus acknowledged the contributions of his many collaborators at Chalk River who helped him push the boundaries of neutron spectroscopy.
It's a reminder that even the most brilliant minds need support, encouragement, and guidance along the way. And it highlights the importance of creating a scientific community that values mentorship and collaboration.
Absolutely. Science is a team sport, and we're all in this together. And that brings us to the end of our deep dive into the world of scientific discovery through the lens of these 5 Nobel Prize-winning lectures.
It's been an amazing journey. We've explored everything from the tiniest subatomic particles to the vast expanse of the universe.
Yeah.
And we've seen how science can be a force for understanding change and inspiration.
We've learned about the power of observation, the courage to challenge the status quo, the importance of technology, the interconnectedness of Earth's systems, and the vital role of mentorship and collaboration.
And most importantly, we've been reminded that science is a human endeavor driven by curiosity, creativity, and a relentless desire to make sense of the world around us.
Right.
So to our listener, we leave you with this final thought. What scientific mysteries intrigued you the most? What areas of research do you find most compelling? And what contributions do you hope to make to the ongoing tapestry of human knowledge?
Keep exploring, keep questioning, and keep pushing the boundaries of what's possible. The world is full of wonder, and the journey of scientific discovery is one of the most rewarding adventures you can embark upon.
Until our next deep dive, stay curious.